Welcome back, and today I'm going to be streaming audio, speech mainly, from the PC, which is the Microsoft Surface Pro, to a myRio, all by wireless. The myRio is over there. It's powered by a battery. As you can see, it's the only one I could find. It's got a small amplifier on it and a little speaker, so I'm going to send some speech over there. This sort of thing could be of use if you've got a robot and you want to send speech to it. Of course, you might also want to receive as well, and I've got another video on that, but actually doing it with the stereo. But in this case, we don't really need high five, we're just sending speech. So on my sample rate is only going to be 11.025 kilohertz. The reason it's such a strange sampling rate is that of course the speech is coming from the PC, and the PC only supports certain sampling rates. For example, 44.1 kilohertz, and multiples of that, divisions of that by 2, so it's 22.050 and 11.025, which is what I'm using. In order to do this, we need 3 programs. We need one program running on the PC, which is this one here, that's the front panel on LabVIEW, myRio. We need a second one on the real-time controller, which is on the myRio, the remote system. And we need a third one here, which is on the FPGA of the myRio. Now, just looking at the FPGA one, how it works is it's just a basic one of those sequences, like a film strip. It does this guy here and then that one and then goes back again. The first thing it does is it delays by 3628 ticks, and with a 40 megahertz sampling rate, if you divide 40 megahertz, that's the, sorry, I beg your pardon, 40 megahertz clock rate of the FPGA, you divide that by the sampling rate, which is 11.025, I think you should get 3628 ticks of the clock. The reason using ticks is if you just use milliseconds, you just got integers, so you can't get the kind of accuracy that you're after. And what we do is we send, we delay it, and then we read the data, which is coming from a real-time processor, and that in turn is coming from the PC. We read it from a FIFO, fast input, fast output memory, and we shove it into the audio out. In this case, just into the left input of the audio out. And these are 16-bit integers. Just have a quick look at the Project Explorer, as it's called. Here's the FIFO here, and it's host to target DMA, direct memory access, and I've put a 2048 length buffer. I'm not sure I really need that length, but well, we can use it anyway. It's not great overhead or anything like that. And the data type is I16, 16-bit integer signed. And so I can go ahead and run that, and what that'll do is if there's anything in the FIFO, it'll shove it out the D2A. There won't be anything at the moment, so I've already compiled it, so it's going, that should run. So what I need to do at the real-time processor, this is on the here under the, in this part of the Explorer. The other part is under the FPGA target. This is the real-time part. I'm going to use the stream command like I did before to go the other direction, and it's really not that hard. The only thing you've got to watch is that it's got, of course, it's got to be done in batches. So we do it in batches of 500. That seems to work perfectly well. And we need the URL of where the data is coming from, and it's coming from the PC. So that data is going to come from the DC, from the PC, and then it's going to be shoved into this infinite while loop, and then the data from the streaming will then be sent in to the data input of the FIFO, which I've just explained goes to the output to drive the loudspeaker. So this is the stream command. This is the create a network stream and create network stream reader endpoint, and that's saying it's 500 integers in the buffer, and this one here is reading the multiple elements from the stream, and then we can display it if we want, and we shove it into the FIFO. So how do we get the data into the from the actual PC itself, though? Now that another program then is run on the PC, and here it is here. And what do we do there? It's a little bit more complicated. I'll explain why in a minute. As we've got commands here which will read from the microphone. This is it reading at 11.025 kilohertz, mono 16 bits. I'm not doing stereo, so that's just the sound VIs, and I'm opening a stream again to send the data, and all I'm doing then is reading from the sound card, but with a buffer length of 500. And I shove that into the stream command, which is here somewhere. Where is it? Ah, there it is, up at the top. The reason it's a little bit more complicated is I've also done it so we can load a WAV file and play that out as a kind of test. It's just for a bit of fun. In order to do that, I have to split once I've read the WAV file, I have to split it up into chunks of 500. So I use a counter where I step up 0, 500, 1000, 1500 and so on, and I read sort of point to the elements in the WAV array once it's read, and I shove that out into the stream. The stream then goes to the real-time processor across the internet. Well, across the internet meaning across the Wi-Fi. In this case, the Wi-Fi is built into the myRio. I don't use a separate router, although I could if I wanted to. And that's it really. So let's run it. I've already run the FPGA program. That's run the real-time program, and I'm going to read a WAV file, and it'll play it out repetitively. So there it is. That's compiled the real-time one. I've got to run it in this order, otherwise it doesn't run. Notice I've got the IP addresses of the writer and the reader. I need to have both of those.
Lower your shield and surrender your ships. We will add your biological and technological distinctiveness to our own. Your culture will adapt to service us. Resistance is futile.
You can see it's repeating. Now I'm going to switch to speech. You can see the WAV there and here. 1, 2. So that's me speaking directly into the microphone, and it's coming out the myRio. I'm just turning the volume down, otherwise it's very hard to speak because I'm hearing myself coming through the small speaker. That's the file that it read. It's not using that at the moment. So just listen to my voice. So there's no shortage of volume there, and I can switch back to the WAV at any time.
Lower your shield and surrender your ships. We will add your biological and technological distinctiveness to our own.
And that's it. So that is how to stream to myRio. So if you had a robot or something and you want to be able to speak to the person at the other end, then you can do that remotely, theoretically from just about anywhere. But here I'm logged into a local network which is on the myRio itself. Okay, hope you enjoyed that. Interesting demo. See you next time. Bye bye.